Now it's not moving. There we are. I think I'm the only speaker to represent that crucial time in the 1960s when John set up his mathematical logic group in Oxford, as Anil was recalling. So let me take it on myself. On behalf of the Oxford group of John's students, first of all, John, to thank you for seeing us through, and second, to congratulate you on your 85th. I'm moving now to somebody who is actually approaching his 80th birthday. This is on my behalf, it's not from the Oxford group. When I thought, what can I talk about in honor of John, it came to mind that both of us had been working in history. So I thought, let's pick up a theme in history. I had some historical notes from 5 years back, which I thought I could use. And that's what I'll be talking about here. Zia Mawahid is best known in Iran as a poet. He recently published a volume of poems about things that are colored blue. And I quoted one couplet from that. In the spring, it was black, and the spring before it, blue. I'm probably not going to refer back to that again, but you may notice when it becomes relevant. Besides being a poet, Zia also has a degree, an Iranian degree in physics and a London degree in philosophy of maths, studying Frege. Now, thanks to his study of Frege and the things he picked up in connection with that, and the things that he knows about Iranian culture, he is in a unique position to compare modern logic with the logic of Iranian logicians from the Middle Ages. And it was in this capacity that in 2003, he wrote this article you see at the bottom, Ibn Sina's anticipation of the formulas of Barcan and Barcan. By the way, Ibn Sina is the same person as Avicenna. I'll try to be consistent and call him Avicenna. Avicenna is actually the Latin corruption of his real name, which was Ibn Sina. In this paper, Zia Mawahid pointed to a passage that Avicenna wrote almost certainly exactly 1,000 years ago, give or take a month or two, 1022, in which Mawahid claimed Avicenna anticipated the modal formulas that are named after Ruth Barcan, modern American, now dead, and Jean Buridan, the 14th century French logician. These three formulas are written in the symbolism of quantified modal logic. Now, there are some immediate points to make here about syntax. Avicenna wrote in Arabic and not in quantified modal logic. Makes a lot of difference. Not only was it a different language, but Avicenna limited himself very much to some kinds of sentence that he could handle. For example, he did write about if-then sentences, but with negligible exceptions. He never wrote such sentences in Arabic together with modal operators. Now, if you look back, you see that all the three formulas here are if-then sentences with modal operators. I don't think this is really important. For example, with the Barcan formula, it would be enough for Movahed to show that Avicenna wrote an Arabic sentence expressing for all x necessarily fx, call it t, call it s, and another sentence, call it t, that expresses necessarily for all x fx, and that Avicenna said somewhere that s implies t. So I don't think there's a problem there. A bit trickier, Avicenna was an Aristotelian logician, and that means that he never used unrestricted quantifiers. I think I'm correct that they came into use in the late 19th century with Peano and Frege. So any sentence that Avicenna wrote down in logic would, if it had quantifiers at all, they would have been restricted. Every B is an A, every B is necessarily an A. For example, concrete examples like every horse is an animal. But what Movahed does, though he does it rather sneakily, is he adapts the Barcan form, the Barcan and so on formulas by implicitly introducing restricted quantifiers into the language. So I've written here, as you see, for all x colon b, that means for every x such that bx, or as we tend to say in this world, every b. So we can write every b is necessarily an a, and necessarily every b is an a. And if Avicenna can write down sentences that express these two things and say that the first implies the second, then I, for one, would be happy to say that he anticipated the Barcan formula. But things are going to get a bit harder here. How do we tell whether a sentence that Avicenna wrote down in Arabic is equivalent to some quantified modal logic formula? We get a little bit of help from one useful fact, and that is that Avicenna uses letters, alphabetical letters, for non-logical constants, exactly as we say P, Q, R, and so on, for predicate letters. This is something that Avicenna borrows from Aristotle. The problem is with the logical parts of the sentences. For example, the word necessary, Arabic daruri. Does it mean the same as box? How do you tell? How would you describe the meaning of box anyway? Let's move on quickly. Now, that covers at least the background to the notes that I wrote on Movahed's claim about the Barcan and so on formulas 5 years ago. Now, what happened there? Well, it was an appendix to a longer piece that was invited for a journal issue in memory of Jaco Hintikar. However, nothing has happened, and I've given up waiting. So I think that the Hintikar article is dead, the journal issue is dead. And instead, I've hauled out those notes, and it's very fortunate that there was a 5-year gap here, because during those 5 years, I had a chance to read Avicenna's earliest surviving logical writings from the first half of his career. As far as I know, I'm the first logician ever to do that. And extraordinary things come out. There are 3 main works involved here. One is called Epitome and Logic. This is a very short work. It's only about 14, 15 pages of Arabic. And if we look to see what the author knew, we can place it with high probability in 993 or 994, when Avicenna was still in his late teens. Now, an important point here, you may have seen pictures of Avicenna, this noble Afghan, at least on his father's side, with the high cheekbones and the staring gaze. As far as epitome in logic is concerned, this is the wrong picture. Instead, you should be thinking spotty teenage nerd. Well, I can't guarantee the spots, but at any rate, the teenage nerd seems pretty solid. So that's early 990s that he wrote that. Very much a student work. Then there's a long gap. The historians tell us that Avicenna had the habit of making just one copy of anything he wrote and giving it to somebody as a gift, and they would never want to pass it on for further copying. And the result is that most of the things that he wrote during the 20 years or so following Epitome in Logic simply never survived. There may be copies lying around in libraries somewhere in Cairo or Istanbul, but I don't have access. At any rate, they're certainly not, they've not been edited. The next major logical work that we do have, it has the curious title of 20 Questions, and we can date it to 1012. It's an unusual style of work if you recognize what's going on in it. It turns out to be almost certainly Avicenna's own private notes in preparation for a larger work called Middle Summary in Logic, which is dated to 1013. So the questions are questions that need to be answered in the process of writing the logical part, the syllogistic part of Middle Summary in Logic. And the two works fit together very closely. By very good fortune, and the first authoritative Arabic edition of Middle Summary in Logic appeared in 2017, edited by Yusuf Sani at Tehran, a colleague of Movahed. Unfortunately, none of these three works have been translated into English. I'll take you through them, what's relevant. It's Epitome in Logic is that first work from the early 990s. It's mostly about syllogisms. It does refer to necessary and possible, though it doesn't say anything intelligible about what either of these words mean. Also, it's the unique surviving modal logic work of Avicenna, which makes no reference to sentences that quantify over time. So it comes from a period before Avicenna had started working on temporal logic. It does have a lot to say about the logical rules obeyed by necessary and possible. That's to say, the inferences, the valid inferences in which these words occur. Interesting, some of the rules that Avicenna sets out explicitly contradict Aristotle. And as far as I can tell, they contradict all other modal logicians before Avicenna. So he's not only a teenage nerd, he's an uppity teenage nerd. In fact, Avicenna makes it clear in this book that his references to the modal logic of Aristotle are not, as is often explained, as is often said in the literature, they are not explanations of Aristotle's modal logic. They are an attack on it. And if you look through later works by Avicenna, he continues to attack Aristotle's modal logic at the same points as in Epitome in Logic, using very similar language. This is true right up until the work pointers that he wrote some 35 years later. Let's just check this. Yeah. So what's going on here? According to Epitome and logic, Aristotle made several mistakes about what logical laws hold for necessary and possible. But if you know the prior analytics, you'll know that Aristotle gave a lot of arguments in support of his claims about validity or invalidity, both in categorical logic and in modal logic. And of course, Avicenna was well aware of these things. I assume that Avicenna had either a translation of the prior analytics when he wrote Epitome and logic, or at least an abbreviation of one. No, that's not an assumption. We can deduce that from the text of Epitome and logic. Well, it follows then, Avicenna must reason, that these false modal laws that Aristotle wrote down rested either on false foundations or on correct foundations wrongly applied. And this word usul, which means foundations, is frequent in 20 questions and also in the book that results from 20 questions. That's Middle Summary and Logic, and nowhere else in Avicenna's logical writings. So foundations is what ties these two works together. Avicenna thought he could point to examples of what he calls rotten foundations, and also to foundations which are quite correct, but Aristotle used them wrongly. So the program, as set out in 20 questions, is to introduce new foundations or new applications of old foundations, as a result of which we can justify all the modal claims made in Epitome and logic. Question: where can Avicenna go for new foundations? You have to bear in mind that nobody had set out any system of logic with new foundations since the Stoics, well over a millennia earlier. And moreover, within the Arabic world, almost nobody knew anything at all about the Stoics. They've been completely absorbed into peripatetic logic, and certainly Avicenna knew nothing about them. So Avicenna had nowhere to look for building foundations except for Aristotle himself and Aristotle's own disciples and followers. So that's what Avicenna does. He rifles through all the odder corners of the logical literature for anything that strikes him as, well, as odd and interesting, that might suggest where he might go to find new foundations. Now, I give 3 examples of his new foundations as he sets them out in 20 questions and then more fully in Middle Summary and Logic. Aristotle proves the invalidity of an invalid categorical syllogism by finding meanings for the non-logical constants that make the premises true and the conclusion false. Now, once you know that that's what Aristotle is doing, and he hardly hides it, this is a source of examples of sentences that we know Aristotle regarded as true, and of sentences that we know Aristotle regarded as false. And rifling through these, Avicenna discovers that apparently Aristotle believed that the sentence, "every horse sleeps," is true, but also "every horse fails to sleep," which looks like a negation of the other one. is true. So Avicenna asks, how can these two sentences both be true? And his answer, quite plausible actually, his answer is that they can both be taken as true if we read them as every horse sometimes sleeps and every horse sometimes fails to sleep. Now you see what he's doing here. He's treating sleeps as a term with two arguments, one where the horse fits in, and the other for a time argument for when the horse is asleep and when the horse is not asleep. So Avicenna is introducing into logic what McCarthy called fluence. And essentially, he's going to build a logic of fluence, a very limited one, within Arabic. Also, taking a hint from Al-Farabi, and I won't go into the details, it's in print. Avicenna argues that the sentence, every horse sleeps, should be understood as saying everything that was, is, or will be an actual horse is at some time asleep. Now you see what he's done here. He's put an interpretation on the relativized quantifier every horse. He's interpreted it as everything that was, is, or will be an actual horse. He uses this formulation very often.
Sorry to interrupt.
Yeah.
When you say Themistian, do you mean Thomistian?
Sorry, when I say
Themistian, do you mean Thomistian?
Themistian.
Where's that
Themistian
come from?
At the top. Yeah, I'm just about to. Oh, right. Yeah. Themistius was a Roman Empire logician, and when Avicenna introduced this new sentence form, he thought he should name it after somebody.
Okay,
so
sorry, I just.
He thought Themistius is the right person.
Thank you very much. That's fine. Thank you.
Bits of Themistius do survive, mostly in Hebrew translation. And looking through them, I can't see what Themistius has to do with Themistian absolutes. But in fact, Avicenna himself seems to have had a similar thought, because in the 1020s, he changed the name. He changed the name from Themistian absolute to broad absolute.
Thank you very much. Sorry to interrupt.
No, well, thank you. Please feel free. That's for everybody. Second new foundation. Now some background here. In the 12th century, Fakhruddin al-Razi, who was one of Avicenna's most distinguished successors in Arabic logic, criticized Avicenna for using the word necessary, daruri again, in two different senses, namely unavoidable and permanent. Sorry. And Razi claimed that this led Avicenna into a state of bumping into things, stumbling in the dark, for which the Arabic is habt. And in several works, Avicenna is accused of habt. Now, Razi is certainly correct that Avicenna used daruri in these two senses. The first sentence, namely unavoidable, the first sense is, this refers to how Aristotle uses the word necessary in modal syllogisms. In particular, then, it's not restricted to any particular kind of necessity like temporal or epistemic or what have you. Von Frisch, in his monograph in the middle of the 19th century, called this alithic necessity, and Mavahid follows von Frisch, and I follow both of them. So unavoidable is alithic necessity. Permanent is what Avicenna introduces in his second new foundation, and Avicenna calls it strict necessity, ad-daruriyil hakiki, though later he quite often shortens it just to necessary. I don't myself think that Avicenna was confused at this point anyway. So Avicenna introduces a new set of sentences. Hey, it's the wrong one. Based on some suggestions of Aristotle's successor, Theophrastus, in Theophrastus's own book, Prior Analytics, which is now long since lost. Apparently, Theophrastus had the idea that you can classify statements using alithic necessity by taking analogues of them, which talk about permanence. Avicenna looked at Theophrastus's examples and didn't much care for any of them, but he found a new example along the general Theophrastus patterns, which runs as follows. Everything that was, is, or will be an actual be, you recognize that, is at every moment when it exists an A. And this he will commonly shorten to every be is necessarily an A, or every be is permanently an A. And this is the sentence that Avicenna tells us expresses strict necessity. I repeat, everything that was, is, or will be an actual be is at every moment when it exists an A. And you see, it begins here with a universal quantifier, everything. Now, Aristotelian logicians follow Aristotle in having four basic quantifiers. One is everything, the second is nothing, the third is something, and the fourth is not everything. So it was taken for granted that the Themistian absolute and the strict necessary should be generalized to so that they can start with nothing or something or not everything. And this way, there's Themistian and absolute and strict necessary is 2, and there are 4 quantifiers. 2 times 4 is 8. So in this way, Avicenna has constructed a new logical language with 8 sentence forms using fluence, for which reason I'm going to call it a 2-dimensional language, 2-dimensional logic. Now, these sentences are interpreted by choosing words for the non-logical constants and reading the temporal quantifiers as quantifying over actual moments of time. This actually leaves no ambiguity about when one of these sentences will be true in the actual world. Hence, it allows us to calculate what inferences are valid and what inferences are not valid using these sentences. So we have an unambiguously determined logic, a very nice piece of work done by Avicenna. He's invented this new logic with new sentence forms, and he also creates a proof theory which proves all the valid inferences for those cases where they're not provable by adapting arguments used by Aristotle. How are we doing for time? Right, here's a third new foundation. Recall, the whole object of the program was to be able to justify valid alithic inferences. And we know right back from Epitome and Logic, that early work, that according to Avicenna, Aristotle did not have a satisfactory way of justifying alithic syllogisms. The third new foundation, again, this appears in both 20 questions and in middle summary in logic. And Avicenna names it using a phrase he borrows from Aristotle's prior analytics, namely counting the possible as absolute. Well, absolute is a word actually from Arabic and not from Greek, but just trust me, this is taken from the prior analytics. Avicenna uses this phrase to mean the following pair of operations. Suppose you've got an alithic syllogism with a possibility premise. Then what you've got to do is to remove the possibility premise and replace it by the corresponding Themistian absolute. Note incidentally that when you do this, the non-logical constants will go from having just one argument to having two. Now, for that reason, if you've also got an alithic necessity sentence as one of your premises, you're going to need a corresponding adjustment. And the adjustment here is that you replace alithic necessity by the corresponding strict necessity. And Avicenna gives quite a lot of examples of this. Now, so in this way, you can take most alithic syllogisms, take their premises and translate them into 2D logic, where we know what follows and what doesn't follow within 2D logic. And then we can read that back to the original alithic syllogism. This marvelously works. It justifies every one of the modal syllogisms that Avicenna claimed back almost 20 years earlier, and Aristotle had rejected. Oh, sorry. So, more or less, the program of 20 questions and middle summary in logic is successfully completed. I am sweeping a number of things under the carpet, and I'm not going to tell you what they are. Now, at this point, another talk would answer the question, yeah, but why should translating from alithic syllogisms into temporal syllogisms of this kind, why should that make any sense? Why should it be a check on the validity of the inferences? And that has an answer, comparing Avicenna's use of the real world with modern use of Crickley frames. But I'm not going to go into that now. Instead, I'm going to say we have, from the program of 20 questions and middle summary and logic, an apparatus for checking the meanings of, the meanings of modal statements, at least to the extent of checking what inferences hold between them. And that's what we need in order to check how the Barcan formula and the Barcan and so on formulas, how these look. Well, we begin with the Barcan formula. Every B is necessarily an A. That does very straightforwardly translate to the 2D sentence. Everything that was, is, or will be an actual B is an A at all times when it exists. The other sentence that we have to look at for the Barcan formula is necessarily every B is an A. Now that's more awkward because in the 10-10s, Avicenna does sometimes write modal sentences that begin with necessarily, but he explains that the place where necessarily is written doesn't make any difference to their sense. It's just as if he wrote them in the middle of the sentence or at the end even. So we're a bit stumped until we come on to the paper of 1022, well, the book, I should say, of 1022, 1,000 years ago, which Mavahe calls attention to. In this book, Avicenna introduces a new kind of sentence where the operator necessarily is, as he says, on the quantifier. And it does appear, I agree with Mavahe on this, that to say that necessarily is on the quantifier is Avicenna's way of expressing that necessarily includes all the rest of the sentence from the quantifier onwards within its scope. Now we have to look back and see what makes sense within the temporal logic as a temporal version of this. And you can check it, but it certainly does appear that the natural 2D reading of necessarily every B is an A, with necessarily on the quantifier, is at every time tau, everything that is a B at time tau is an A at time tau. So we have here, that's sentence 2 for the second sentence of the Barcan. And we already found sentence 1, a strict necessity sentence, for the first sentence of the Barcan formula. Now we can confirm that 1 implies 2, because both of them are in 2D logic and the whole thing is decidable. We will need one further assumption, which I perhaps should have mentioned earlier, and that is Avicenna assumes everything that has an affirmative property at time tau exists at time tau. So let's call that star. To prove Barcan, assume the first sentence and let tau be any time, and let little a be something that's a B at time tau. Now by sentence 1, it follows that little a is an A whenever little a exists. So all we need to do is to show that little a exists at time tau. Well, that's all right, because at time tau, A has the property of being a B, which is affirmative. No negations there. So by star, little a exists at time tau. Hence, little a is an A at time tau, proving 2. That shows that the Barcan formula holds when interpreted as we've interpreted it. Also, this proof works for the negative Barcan formula with not A in place of A. This is worth saying because we've seen a couple of places where Avicenna, rather confusingly, introduces the notion of affirmative into the rules, the logical rules. But it turns out that the negative Barcan formula is all right still. However, and I leave it with you, the converse Barcan formula fails. Also, it's not hard to find corresponding expressions to the expressions for the Barcan formula, but again, the implication fails. Now, there is a point here. It's received wisdom that if what you really want is to have Barcan and converse Barcan, then you should work in a mobile system where every Kripke frame has a single universe, the same for all worlds. Now, Avicenna's 2D logic does require models with a single universe, the same for all times, which are the what corresponds to worlds. But the complication is that there's also an existence predicate which selects for each time tau those things that exist at time tau. So as you run through the times, you've got a kind of for each time a set of those things that exist at that time, and this set expands and contracts within the single universe. So it's not a straight single universe. Well, Mavahed's claim was that Avicenna himself claimed the Barcan formula, in effect, that one implies two. I can't go into the details of this here because this involves translations of medieval Arabic, and you won't thank me for that. But the IGPL article reporting this lecture will go into details. My belief is that Mavahed mistranslated a key word, and the passage that he cites as saying that one implies two doesn't say anything of the sort. However, the next sentence is all right. It does imply that. At least it can reasonably be read as saying that the Barcan formula holds. I can't find anything in Avicenna's text to justify the claim that he supported the converse Barcan formula or the Barcan formula. But then, as we've said, the Barcan formula holds in the Arabic version using the 2D semantics, but the converse Barcan and Barcan formulas don't. So it does seem that Avicenna got it right, and all credit to Mavahed for doing that, for pointing this out. Oops. I have a couple of footnotes. This is on my website, by the way, if anybody wants them. Footnote 1 is just to explain one of the things I swept under the carpet. Footnote 2 is an interesting point here, that a few years ago, Spencer Johnston, who was completely unaware of Avicenna's modal logic, found a Kripke-style semantics to validate Buridan's divided modal syllogisms, and it had a clear resemblance to the modal semantics of Avicenna using 2D logic. One difference was that Buridan's necessarily an A, wasn't an A whenever it exists. It was always exists and is always an A, so it's very strong. Very recently, a Lithuanian group who are engaged in putting all of Buridan's syllogisms onto a computer found that in another work of Buridan, there are hints of a semantics which is actually even closer to Avicenna. It's intriguing. There's no line of historical transmission from Avicenna's logic to Buridan's is known at all. So we wait to hear more that people can discover here. Here are a couple of references. My paper was Spencer Johnston, and this very recent Lithuanian paper, 2022. Right, I'll stop there.